555 timeric, internal block diagram. Voltage divider. Between the positive supply voltage, VCC, and ground, GND, is a voltage divider. It consists of 3 identical resistors, 5 kiloohms for bipolar timers, 100 kiloohms or higher for CMOS, creating reference voltages for the analog comparators. The control pin is connected between the upper 2 resistors, allowing an external voltage to control the reference voltages. When control is not driven, this divider creates an upper reference voltage of 2/3 VCC and a lower reference voltage of 1/3 VCC. When control is driven, the upper reference voltage becomes control, and the lower reference voltage becomes 1/2 of control. Threshold comparator. The comparator's negative input is connected to the voltage divider's upper reference voltage, and the positive input is connected to threshold. Trigger comparator. The positive input of the comparator is connected to the voltage divider's lower reference, and the negative input is connected to trigger. Latch. A set reset latch stores the state of the timer, and is controlled by the 2 comparators. Reset overrides the other 2 inputs, allowing the timer to be reset at any time. Output. The output of the latch is followed by an output stage with push-pull output drivers. It can supply up to 200 milliamperes for bipolar timers, and less for CMOS timers. Also, the output of the latch controls a transistor acting as an electronic switch that connects discharge to ground, convenient for discharging a timing capacitor, or leaves it disconnected. Ground supply. This pin is the ground reference voltage, 0 volts. Pin configurations. 2. Trigger input. When trigger falls below 1/2 of control, 1/3 VCC, except when control is driven by an external signal, output goes to the high state, and a timing interval starts. As long as trigger continues to be kept at a low voltage, output will remain in the high state. 3. Output. This pin is a push-pull output that is driven to either a low state, GND, or a high state, VCC minus approximately 1.7 volts for bipolar timers, or VCC for CMOS timers. For bipolar timers, this pin can drive up to 200 milliamperes, but CMOS timers are able to drive less, varies by chip. For bipolar timers, if this pin drives an edge-sensitive input of a digital logic chip, a 100 to 1000 pf decoupling capacitor between this pin and GND may need to be added to prevent double triggering. 4. Reset input. A timing interval may be reset by driving this pin to GND, but the timing does not begin again until this pin rises above approximately 0.7 volts. This pin overrides trigger, which in turn overrides threshold. If this pin is not used, it should be connected to VCC to prevent electrical noise accidentally causing a reset. 5. Control input. This pin provides access to the internal voltage divider, 2/3 VCC by default. By applying a voltage to this pin, the timing characteristics can be changed. In astable mode, this pin can be used to frequency modulate the output state. If this pin is not used, it should be connected to a 10NF decoupling capacitor between this pin and GND to ensure electrical noise doesn't affect the internal voltage divider. 6. Threshold input. When the voltage at this pin is greater than 2/3 VCC, by default, except when control is driven by an external signal, then the output high state timing interval ends, causing output to go to the low state. 7. Discharge output. This pin is an open collector output for bipolar timers, or an open drain output for CMOS timers. This pin can be used to discharge a capacitor when output is low. In bistable mode and Schmitt trigger mode, this pin is unused, allowing it to be used as an alternate output. 8. VCC power. Positive supply. For bipolar timers, the supply voltage range is typically 4.5 to 16 volts. For CMOS timers, the supply voltage range is typically 2 to 15 volts. Decoupling capacitors are generally applied between this pin and GND as a good practice.